So in our previous video we treated LCM of two given numbers, and after class we had two assignments, which were one to find the LCM of 5 and 7. The second one was to find the LCM of 4 and 5. Though I asked you to drop your answer, but it will be good if we provide solution to our assignment. That way you know if you got it correctly or not. So the first one, which is 5 and 7, so we need to find the LCM of 5 and 7. So we use the same method we've been using before now, so that way we will know the answer if we got it correctly or not. So what can divide 5 and also divide 7 without a remainder? Well, there's no number that can divide 5 and 7 without remainder, so we'll have to divide 5 first by 5, and that will give us 1. Since 5 cannot divide 7 without a remainder, we have 7 here. So next we divide 7. So we'll come here and say 7 dividing 1 will be a fraction, so we have 1 here, and 7 divided 7 is going to give us 1. So we have 5 times 7, and that gives us 35. So that is the LCM of 5 and 7. So if you got 35, kudos, you got the answer correctly. So we'll be treating the other assignment, the assignment number 2, which is the LCM of 4 and 5. So example 2 says the LCM of 4 and 5. So we have 4 here and we have 5. So we need to find the LCM of 4 and 5. So like we'll be doing, we need to divide 4 and 5. So is there any number that can divide 4 and 5 without a remainder? No, there's no number. So you can actually go by saying 2 divided 4 gives you 2, and 2 cannot divide 5, so we have 5 here, and then we come again, 2 divided 2 gives you 1, so we have 5 here. Next we divide 5, so 5 here is 1, 5 here is 1, so our LCM there is 2 times 2 times 5, and this gives us 20. So if you got 20 as your answer, then you know you got it correctly. So that is the solution to our assignment on our previous topic, which was LCM of two numbers. So we can start today's topic, which is LCM of 3 numbers. While finding the LCM of 2 numbers was quite simple and straightforward, it applies to finding the LCM of 3 numbers. But that doesn't mean you will have to do extra work. No, it's all the same thing. So assuming we have 3 numbers and we're asked to find the LCM, we'll still use the same method, which is the long division. And we'll take an example here. Assuming we have 3, we have 6, we have 7, and we're asked to find the LCM of these 3 numbers. So what do? We already have an idea of how to find the LCM of 2 numbers. So remember, when we started, we said bring down your long division line, and then we put the numbers here. So we have 3 and we have 6. Now we have 3 numbers, so you bring the third number here, which is what? 7. So we start by dividing the numbers then. So what number can divide 3, can divide 6, and can also divide 7 without a remainder? Well, no number. There's a number that can divide 3 and 6 without a remainder, but that number cannot divide 7 without a remainder. So we first have to go gradually, like we did in the LCM of 2 numbers. So if we use 3 here, 3 can divide 3 without a remainder, and it will give us 1. 3 can divide 6, and it will give us 2. But since 3 cannot divide 7, we have 7 right here. So we'll move to the next line. What can divide 1, 2, and 7 without a remainder? Essentially, at this point, we're interested in dividing 2 first. So we know we have to bring 2, and here will become 1. Then 2 divide 2 will give us 1. And 2 cannot divide 7, so we still have 7 here. Alright? Yes. So next we have to divide 7. And the only number that can divide 7 without a remainder is 7 itself. So we have here 1, 1, 1. So at the end of the day, we have 3, we have 2, and we have what? 7. All you need to do is to introduce your multiplication sign here, and then we are good to go. So 3 times 2 will give us 6. You get it? Then we move to the next one, which is 6 times 7, which will give us 42. So the LCM of 3, 6, and 7 equals what? 42. So this becomes the LCM of our first example. Next we'll be taking another example, so we'll become familiar with treating or solving problems of LCM numbers that are more than 2. So our second example says we should find the LCM of 3, 4, and 5. 3, 4, and 5 are 3 numbers, and we just completed first example on how to find the LCM of 3 numbers, so this shouldn't be difficult. If you want to try your memory, you can pause the video and try and solve it, but in the meantime we'll provide solution to it all together. So we'll start the same way using the long division. So we have our numbers, which is 3, we have 4, and then we have 5. So as we all know, we're looking for a number that can divide 3, 4, and 5 without a remainder. Unfortunately, there's no number, so this is quite straightforward. 3 can divide 3 without a remainder. We have 1, we have 4 here, and then we have what? 5 from our previous example. So next we divide again. So here becomes what? 1, yes, and here becomes what? 1. Since 4 cannot divide 5, we still bring our 5 down here. So next we use what? 5. So here becomes 1, here becomes 1, and here becomes 1. So at the end of the day, we are left with these guys here. So it becomes 3, 4, and what? 5. Notice how it is 3, 4, 5, 3, 4, 5. So these numbers have nothing really common among them, except that the LCM for all of them is by simply multiplying all of them together. So what we do, we introduce our multiplication sign here, and then we begin our multiplication. So if we multiply 3 times 4, we have 12, and then 12 times 5, 12 times 5 will give us 60. So 60 becomes the LCM of 3, 4, and 5. So for those of you who actually tried before watching the video to the end, check if you got the answer correctly. If you do, kudos to you. If you fail, that's not the end of the world. You tried, and then you check where you made your mistake, and then you make amend. So this is how we find the LCM of 3 numbers. Essentially, in this tutorial, if you are still new to this channel, do ensure you subscribe to this channel so that you can be getting new videos when they are uploaded. I'll be dropping how to find the LCM of 4 numbers. Essentially, that will be our next topic, and stay tuned, don't go away. We'll kickstart that topic immediately. Hello, welcome back to today's tutorial, the continuation of our already existing topic, LCM, which stands for lowest common multiple. Yes, and I already told you to keep in mind that when you're looking for LCM of numbers, we're talking about the lowest number which can be divided by 2 or more numbers without a remainder. That's the main thing, without a remainder, and the least number. So in our previous videos, we already treated how we can find the LCM of 2 numbers. Now in other videos as well, we've treated how we can find the LCM of 3 numbers. So we want to find the LCM of 4 numbers. Once you have a good understanding of how you can find the LCM of 2, 3, and 4 numbers, no matter the numbers of numbers you are given, you will be able to find their LCM. So we'll begin with our very first example of the day, which says find the LCM of 2, 4, 5, and 7. And as usual, we first begin by writing them down: 2, 4, 5, and what? 7. Now what do? We bring our long division line, then we put our numbers which we want to find their LCM. The first number on the list is 2. Then we have what? 4. Next we have 5, and then we have what? 7. So like we always know, we're looking for a number that can divide 2, 4, 5, and 7 without a remainder. Now there's no number which can divide 4 of those numbers without a remainder, so we go gradually as we used to. So we first of all have 2. Since 2 can divide 2, and when 2 do divide 2, we have 1. 2 can also divide 4, and we have what? 2. So 2 cannot divide 5 without a remainder, so we have here to be what? 5. Same thing with 7. 2 can't divide 7 without a remainder, so we have what? 7. Next we divide again 2. 2 cannot divide 1 without a remainder, so we have what? 1 here. And when 2 divide 2, we have 1. The same thing goes for 5 and 7. 2 cannot divide 5 without a remainder, neither can it divide 7 without a remainder. So next we have to find what number can divide 5 and 7 without a remainder. No number actually. So we have to divide with 5. So when 5 divide, here we have 1, 1, and 5 divide 5 is going to give us what? 1. Since 5 cannot divide 7 without a remainder, we have 7 here. So next we divide with what? 7. And here becomes 1, 1, 1, and 1. So at the end of the day, what we have is 2 times 2 times 5 times what? Last digit there is 7. So 2 times 2 gives us 4 times 5 gives us 20. Then 20 times 7 gives us 140. So we have 2 times 2 times 5 times what? 7. So we are going gradually. So here we have what? 20 times what? 7. So at the end of the day, our final answer becomes 100 and what? 40. So the LCM of 2, 4, and 5 and 7 is 140. This is a very common example or common question in some past questions I've seen, and we'll take one more example before we conclude today's topic. So assuming we have 5, 7, 8, and 12 as another example, which is we're asked in this very example to find the LCM of 5, 7, 8, and 12. So as usual, we go by writing them down: 5, 7, 8, and what? 12. So if we are going to use our long division method, we know what to do already. So we bring them down, the numbers we are given to find their LCM. The first number on the list is 5, then we have 7, we have 8, and then we have what? 12. Pardon my writing, it might be bad, but hopefully you get the gist. So on the list there, 5 and 7 cannot be divided by any other number without a remainder. So we first have to divide those two. So we have 5 divided 5 to give us 1. So we just have to bring down the other numbers: 7, 8, and what? 12. So next we divide 7. So here we have 1, 1, 8, and what? 12. So like so. Now we want to divide 8 and 12. 8 and 12 have a common divisor. 4 can divide 8, and 4 can also divide 12 without a remainder. So if we have 4 here, here will be 1, 1, here will be 2, and here will be 3. So next is going to be to divide 2 and 3. So if we have 2 here, here will be 1, and 2 divided by 2 will give us 1. 2 can't divide 3 without a remainder, so we have 3 here. So next is to divide 3. So we have here to be 1, here will be 1, here will be 1, and 3 divide 3 is going to give us 1. So at the end of the day, we have 5 times 7 times 4 times 2 times 3. So 5 times 7 times 4 times 2 times 3. Next is for us to find the answer. So 5 times 7 is going to give us 35. So multiply again by what? 4. Multiply by 2 and multiply by 3. So 35 times 4 will give us 140. We have 140 times, I already know that 2 times 6 is what? 2 times 3 is what? 6. But if you still want us to do gradually, we'll do that. So 2 times what? 3. So 140 times 2 will give us 280 multiplied by 3. So 280 multiplied by 3, if you get it correctly, the answer is 840. And this becomes our LCM of those 4 given numbers. So you can already see that, okay, it is not usually as simple as when we are looking for the LCM of 2 numbers or 3 numbers. Sometimes it's way more bigger. So the LCM of 5, 7, 8 and 12 is 840. So you can, if you want to try your hand on more examples. So before we go, we have 2 assignments for you, an LCM of 4 numbers. So our assignments are just 2, just like we had in when we were treating LCM of 2 numbers. The first assignment there says we should find the LCM of 2, 5, 8 and 12. So that is quite straightforward, which is 2, 5, 8 and 12 is the first one, and the second assignment is the LCM of 3, 4, 9 and 11. So try your hand on these assignments, and then you can be using this to checkmate your progress, your understanding of LCM from the beginning of this series. So we'll see you in the next video. Don't forget to subscribe to the channel, hit the like button and share, comment, share with us your experience so far, your engagement on the channel, share your answers. It will help to make further more videos on where you find the problems along the line. So see you in the next video.